So today talk is about the introduction. I'll talk about it. My name is Musa Komikomo. Actually, I was working 25 years in University of Glasgow in UK and 5 years in the United States. So I joined Moorcroft University just last year. So I hope to enjoy, and my aim is to contribute to you, and I hope everybody listen and learn as much as they can, because your job is very important in the future. You're going to be a doctor. That's why you have to study hard. You have to use this opportunity to increase your knowledge as much as you can, because after you finish, you're going to deal with the life of the people. So you are a very responsible person. So if you didn't take these science seriously, in future you might have a problem. And I don't like the people to think about the marks, I want this mark and that marks, because students should work for the marks. Students have to work for the knowledge, to learn it. Because after you graduate, the marks is not going to help you out at all. What you learn is more important. Because when you're facing with the patient, sometimes you have 5 minutes to make a decision what to do, because if you delay 5 minutes, the patient will die. So the marks is not going to help you out at all. So it's better to learn as much as you can. Last year I wasn't happy with the students because most of the students just passed by borderline. It's not very good. I have just 2-3 students with above 90%. 3 students among 170 is not good enough. I hope this year you guys try it a bit harder. Okay? So it's a guide to the students. You have to know this one, because all the students have to be in the class 15 minutes before the talk. Actually, I don't like the students come to the class after I attend and talk. Because if they start to talk, I don't like somebody come and do, because the interruption is not very good. So, and the other stuff, because every student, if they absent for 20% of the talk, they receive later. If the absence is more than 25%, they're not allowed to take the exam in the final. And 10 points goes for the presentation that Dr. Imam mentioned to you. And 5 points for your behavior and especially behavior. I like everybody, all the students, be quiet when I talk. And for attendance, for your attendance. So there's 2 exams, 1 midterm and 1 final. And the learning objective will be in all the courses. And as I say, you're going to call this book for your lecture. The references is this one. Yeah, the lecture is included, 10 lectures included in the course. So I present the first one, and the second, third, fourth, and fifth one, Dr. Imam will present, and then I'll come back again for the rest of the courses. And the last one, I mentioned presentation, because as Dr. Imam mentioned, you're going to present your side. If the number couldn't finish on time, all of them will be presented. So the learning objective for this session is to define immune system. And I'm going to give you overall picture of the immune system, how the immune system is working. What I'm going to cover today will tell you detail in the last 10 hours, okay? So what I'm going to say, I'll give you the overall picture, what's happening in the immune system, and then we go detail one by one later in the next lectures. So the immunities, the word is coming from immunitas, is the Latin word that the people who was working in Roman Senate, they using the immunity or immunitas, which they protect them against legal prosecution. I mean, as far as they were in the Senate those days, nobody can prosecute. They had immunity. The word immunity comes from that. But now, the immunity means the body function against diseases, especially infection. Immune system is the collaboration and is the containing the combination of the tissue, cells, and the molecule they involve this immune system. So is the immune system is the tissues, some cells, and some molecules. They are immune system. How they collaborate with each other, the collaboration is immune response. By collaboration of these cells and molecules, the immune responses happen. And immunology is the science which covers the mechanism and how it works. The immunity is actually talking about the self and non-self. So if something enters to your body and your body considers it as a non-self, they start to react against it. So the immune system differentiates from the self to non-self material. So if it is self, there is no reaction. For example, you know that if somebody has a blood group O, if they receive group O, there is no reaction. But if you inject them group A, the person dies in just 5 minutes, very quickly. So the immune system rejects non-self and accepts the self. So the whole thing in the immunology is talking about the self and non-self. Now what is the non-self? You can see it here. For example, cancer, all the pathogen, parasites, viruses, and also the bacteria and toxin, all is non-self. If these material enter into the body, the immune system will reject it. What is the rule of immune system? So as you can see here, defense against infection. So they repair all the infection. If there is a deficiency, because as I said, the immune response is a collaboration between the tissue, cells, and molecules. If there is a deficiency in each part of it, the system fails. And the severity of the system comes the importance of that particle, because some of the particle is very crucial, and some of them are not. If the deficiency target the most important part of the immune system completely will fail. But most of the time, fortunately, immune deficiency target is the very partial part, and the system can overcome the problem. But some of the diseases, as I mentioned here, and you heard before, is AIDS. AIDS is the disease caused by the HIV. This virus is very smart. What they do, they target the most important part of the immune system, and that's why the whole immune system collapses and paralyzed. When the system is paralyzed, all these material, virus, cancer, parasite, bacteria, attack the body and completely destroy the host. That's why the severity of AIDS here, because the AIDS virus target the most important part of the immune system. How we can improve it? So the one of the way is vaccination. So if you vaccinate it against any bacteria or any infection, you actually can increase and boost the immune system to confront the infection. I'm sorry because I have a very bad catch cold, so you have to. Immune system has some advantage and disadvantage. The disadvantage is in transplantation. If you have a transplantation, the immune system will reject it. But there is some advantage as well, because it can fight against the tumor. That's why they use these techniques to have a immunotherapy to treat the tumors. So, as I said, one of the ways to boost the immune system is vaccination. And vaccination is used many years before. The first written example is the Chinese. They used to use the particle of the pustules remain on the smallpox on the skin. They take it out from the patient and scrap it on the children's hands. By this way, they can immune them from the smallpox. So they usually do it in the 15th century, but the first practical one is done by a British physician called lec.1. So he find out the milkman, who usually, in England, even now, there is a guy, they call it milkman. They bring the milk and put the milk in front of each door. So whenever they wake up, they come and open and take the milk, fresh milk. So they find out the milkman, he had a cowpox. He never get smallpox. That's why he took the material of the cowpox and injected to the hand of the children, and he find out they can protect these children from the smallpox later. And after that, a lot of people actually comes and they generate a lot of vaccine, including diphtheria, measles, mumps, pertussis, polio, and etc. And this is the year they usually establish that one. And these are the numbers they used to be during the first early days. But when they calculated in 2004, the number of the incidents is declined very much, and sometimes even 100%. But some others still are large. The reason some of them is not eradicated very well or not controlled very well, because some of these bacteria have a carrier. Means the carrier are those people who have the virus or infection material, but they don't have any symptoms. That's why they cannot be recognized. So that is one of the problems. Some of the vaccine doesn't work very well. As you know, smallpox is eradicated completely in the world. So the vaccination is boost the immune system and improve the immune system. If you ask me a specific question, and then I can answer. Yeah, after the class. If anybody didn't understand it, you can stop me and ask the question. Anytime you don't understand what I'm saying, just stop, raise your hand, and ask the question. If you have a specific question, after, yeah, we can talk. So it is the process of the immune system. You have outside the body, inside the body. There's the confrontation of the outside and inside. So the microbe and all the pathogens, when they want to enter to the body, the first barriers is physical barriers, including mechanical, chemical, and biological. If they pass through these barriers, the innate immune system confronts them, and then finally adaptive immune system completely eliminated and destroyed. This is the pattern of the immune response we usually have. Adaptive immunity, there is two types. There is active and passive. Active, it is when you get sick. When you get sick, your body responded, and if you expose the same antigen, you have immunity. You never get sick again with the same pathogen. So this immunity is active because your body development is acquired, is developed by yourself. But sometimes the immunity, adaptive immunity, can be passive. Have you passed microbiology?
No.
No. So there is two microbes usually attack to the human in two different ways. One, they call it by virulence. The second form is by toxicants. So the virulence is the pathogen gets into the body, when it goes to the tissues, they increase the number. By increasing the number, they shows the infection. But sometimes the number is not the matter. They produce toxin, like bacteria. So they don't need to increase very much in the body. As soon as they get infected, they produce a toxin, and toxin is very lethal for the host. In that cases, when those bacteria produce toxin, the toxin affect very quickly and sharp, because in virulence form, it takes several days to develop. At the same time that the bacteria is increasing, the immune system is also developing, so they can target the virulence bacteria very easily. But when the bacteria is affected by the toxin effect very quickly, didn't let the immune system to develop. So in that case, you have to transfer the immunity from the safe person to that one. That's why they use anti-serum. Or you have seen about the snake bite. The snake bite, if somebody bite by a snake, if you don't use anti-serum in 1 hour, like might die. So whoever the immune system can confront it, but it takes time, 5-6 days you will see it. In that case, you have to have a passive immunity. So the passive immunity, it means the person didn't develop it, but received from the other same person. So active and passive, do you understand the difference?
Snake bite, it's a toxic substance.
What?
Toxic substance, snake bite. The snake bite. Snake bite.
Yeah, but what bacteria? As I say, bacteria is an example.
It's development immunity system inside the body.
They develop it, but it doesn't give you time before your immune system develop, they kill you.
No, but the radio therapy.
Yeah.
This snake.
It's anti-serum.
Yeah, anti-serum.
Yeah, they use an anti-serum, they take anti-serum to the patient, and then they keep you safe. Or a scorpion, even the scorpion and a lot of loss. There's your absence sheet. You have it. It's finished. Actually, immunology is all about surface receptor and their function. If you understand surface receptor and their function, you know all about the immunology. Because whatever the reaction happens in the immune system, it is done by the receptor. As you can see here, innate immune response, they have a receptor, and also adaptive immunity, they have a receptor. The difference between these receptors is innate immune response have identical receptor in all individuals. It doesn't matter who you are, you have the same receptor. The same receptor. That's why if the pathogen comes to your body, everybody react exactly the same way in innate immunity. The innate immunity response in all individuals is completely identical, is unique. There's no difference between them, unless if they have some deficiency. That's the different story. If the normal person, the healthy person, if the people confront to any pathogen, the innate immunity confronted completely identical. But in adaptive immunity, the response is completely different from one to another. Why? Because their receptor is completely different. So the reaction can be completely different. That's why some people is very sensitive to some diseases, some are not. And we will talk about the function and generation of these receptors later in detail. Okay, so we say the immune system is included immune tissues. The immune tissues divided into two different sections. One of them they call it generative or primary or central tissues. Another is secondary tissues. The central tissue are those tissues that make the immune cells. The immune cells develop there. So including bone marrow, which is the most important part, because most of the immune system cells generated in the bone marrow, but some cells, like T cells, they go to the thymus to develop further, or there is a bursa section in the chicken, the B cells develop there. In human, all generation of the B cells happen at once. So the central tissue are those tissues which are responsible for generation of the immune cells. But secondary lymph node tissues, including spleen, lymph node, and some mucosal and cutaneous immune system, they are responsible for immune reaction. So the cells develop here, they goes to this section, they confront the antigen. So the reaction between the immune cells and the pathogen usually take place here. And these are not responsible for that. They provide the cells and they goes here and they confront the pathogen in the immune system, which will tell you later in detail. As you can see here, this picture shows the location of the central and secondary immune tissue. This is the thymus, and bone marrow is central, and the spleen, and all these lymph nodes are the secondary. And these lines you can see here is lymphatic tissue. So through these veins, the cells, immune cells, goes from one lymph node to another by circulating the brain. As you can see here, there is plenty lymph node here, 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 and just there is one here, one here. Why? Why do you think so?
Because drainage of the bacteria veins.
No, because here, as I say, the first barrier of the body against the pathogen is physical, the skin. The skin is the first barrier. So the penetration of the pathogen through the skin is quite difficult, unless it's broken somewhere. But if you look at in this area, around your mouth and your lung and your gut, there is smooth. There's not skin there. And as you know, there is plenty bacteria in your gut. And there is plenty bacteria that goes to your lungs and is here by breathing. So the confrontation to the pathogen is more might happen here comparing your legs or arms. That's why there is more lymphoid organ around that area to protect you from the infection. So as soon as the pathogen gets through there, they will capture it and the immune response will start. And this is the structure of the lymph node. Basically, I can tell you these two important sections. One is the, for example, it is each high endothelial area. It is the place that usually the cells get into the lymph node. If they are B cells, they goes to the follicles. And when they activate it, they make general receptor. So the B cell, then they come here directly to the cell. But the T cell stays in this area. The area of the B cell and T cell is completely different. And that is the immune stain. You can see here the stain the B cells and the T cells with different color. You can see mainly the B cell over here and The T cells here, yes. T cell, yeah, is in the cortex is here. Is in the yeah, T cell is here. Actually, they don't stay here. When we go further, give you detail, they move around and it's very complex system.
Now, the main function of the main functions.
The main function.
Maturation or
No, it's not the maturation. Maturation happens in the bone marrow. All the marrow, generation means maturation. The generation and maturation happen in bone marrow, but in the case of the T cell, they generated in the bone marrow for maturation, they go to thymus. It's the only difference. But the rest of the immune cells, generation and maturation happen in the bone marrow. But the lymph node is the immune reaction happen, is the confrontation with the pathogen. Yeah, they mature, completely mature, so they are functional. They move to the lymph node, they stay there for confrontation to the pathogen. So the immune reaction is happening in the secondary lymph node. The primary is the bone marrow, is for generation and maturation. Yeah. There is no immune reaction here. Yeah, we'll tell you the detail. It's very good story actually. It's the good thing in immunology is the not looks like anatomy to memorize a lot of things. You have to understand and imagine what's going to happen. It's very, I think I like immunology very much. So I changed my major a couple of times. Finally, I just because I went to the medical school, and then I went to microbiology, clinical microbiology, and then I went to immunology and stayed in immunology because I like immunology very much. Actually, immunology is very important for your career. If you look at most of the, because the treatment of the acute diseases like infection is very easy. Every doctor have to know how to treat the infection. That's very easy thing. But the most important is chronic diseases. The root of the chronic diseases somehow, I can tell you 70% of the chronic diseases somehow is related to immune system. Dysfunction, overreaction, whatever you can call it. 70% of the disease, the root and etiology is related to immunology. So it's better to understand immunology because it can help you to understand diseases later in maybe third, fourth, and fifth lectures because all the time people might use some of the terminology which I'm using here because in all the, for example, if somebody are going to be dermatologist or rheumatologist or respiratory medicine, 80% is immunology. If you don't understand immunology, you cannot understand any of those. Immunology is very important for etiology of the disease. So take it seriously. I think we will take advantage of it. So the immune cells. And the immune reaction is the collaboration between non-immune cells and immune cells. Non-immune cells like fibroblasts, smooth muscle cells, and epithelial and endothelial cells. So whether they're not part of the immune cells, but they help immune cells enlargement. And we'll tell you how they help them later. And the immune cells including monocyte, WBC, yes, it's including monocyte, lymphocyte, eosinophil, neutrophil, mast cells or basophil, and endothelial. Mast cells are in the tissue, basophil is in the blood. And monocyte, and we have macrophage here because if it is in the blood, we call it monocyte. When they migrate to the tissue, we call it macrophages. So these are the main cells in the immune system. As you can see, you can differentiate it by staining. By staining, you can differentiate by the shape, the shape is different, and some of them are acidophilic, and some of them is basophilic. The color and the shape is completely different, because if you stain them and look at them under the microscope, most of the time you can differentiate.
You can say for, if we had for all of them, it's WBCS.
Yeah, all is YBC.
YBC.
YBC. So as I said, you can differentiate very easily. By looking at their shape, you can find out they are eosinophil or mast cells, because their granule completely is different from the granule.
What's this?
But the lymphocyte included T cells, B cells, and natural killer cells. You cannot differentiate by the morphology.
Doctor, was it DC? What's the meaning of DC?
Right?
DC.
What's the meaning of that?
This
The
one.
last one, yes.
Dendritic cells. Dendritic cells. Dendritic cells. Yeah. It's written in your no.
Okay. But about muscle, we know it's really very resistant in the blood vessels. What's the function for it in the immunology?
Yeah, you go too far. You include it in the
Because I
next.
understand, because it's
Yeah.
the blood vessels.
Yeah, because you have to understand the basic to be able to answer that question. We will include it in the next lecture, or maybe in the sixth one. You are far ahead of the course. Because we tell you the function of all these cells and what they do and when they do. Because here, as I mentioned, it's just overall picture. I want to know what the immunology is and what is included. The detail, me and Dr. Leonard will tell you little by little. I am not going to tell you any detail now, because we have to go step by step to be able to connect all these subjects together. But if I go something here and then something here, you cannot connect it together later on. But if you go primary one, you can do it. For example, if you have primary one, primary two, primary three, and four. And if you jump from primary 1 to 6, you miss the link. So the lymphocyte, as I say, is the morphology. You can include the T cell, B cell, and natural killer cell. By morphology, you cannot differentiate. How to do it, we tell you later. Okay, so when the antigen or allergen get into the system, collaboration of these cells make the immune response. The immune response most of the time is protective. They save you from the infection. But sometimes the immune system have overreaction or have a malfunction. In these cases, energy diseases, and most of the chronic disease is here. And also one other way that the main disease is immune deficiency. And it depends what kind of deficiency and where there are, it can be very lethal. For example, here, if the T cells is infected, is dead, is finished, everybody is done. The HIV do exactly the same thing. They destroy the T cells, which is the mastermind of the immune system. When they destroy the T cells, none of these cells is going to be functioning. We will see later. Yeah. Because the T cell is the mastermind of the immune system. So the immune deficiency, it depends, the severity of disease caused by immune deficiency, it depends which part of these cells or molecule is targeted. If the molecule is very important, the disease and severity is very high. If it's not very important, the immune system can overcome the problem and sort it out. So the immune system will tell you how many cells we have. So they have different functions. Some of them are phagocytosis. They engulf the bacteria and destroy it, like monocyte and macrophage in the tissue and neutrophil. Some of them is granulocytes, like eosinophil and mast cells, which is very important in parasite infection and allergy. They tell you what to do and infection. And some of them we call it antigen-presenting cells. What they do, they take up the antigen and give it to the T cells or give it to the B cells. So the function is they initiate the immune system. When the pathogen gets into the body, these cells are responsible to capture it and give it to the T cells. So that's why they call it antigen-presenting cells. So each cells have different function. We will go through each of them in detail later. How they do that? How these cells communicate with each other? This is the picture of the lymphocyte. As you can see, there is a lot of particles on the cells. These are receptors. Some of the receptors are on the cells all the time, but some of the receptors come and go. They come, then they receive the signal, they do the job, and get into another thing. So some of the receptor is expressed on the cell all the time, but some of the receptors come and go. As I said, we want to know how these cells collaborate with each other, how they do it. One of the ways is this receptor. So antigen-presenting cells, for example, when they capture the antigen, they go to meet the T cells, and this receptor gives signal. When they touch each other, they give the message to the T cell, and the T cell know what to do after that. As soon as they give the signal, they know. Another way they do it, by production of the protein, they call it the cytokine. So the communication of these cells by each other is through the receptor and also through the protein they call cytokine. By cytokine and the receptor, they can make the immune response possible. Is it clear? They call these receptors CD marker, cluster of differentiation. So there is a lot of CD marker on the immune cells, is more than thousands, maybe more. So you're not going to include all these receptors because each receptor do their own, they have one function, different function. Some of the receptor is used for identity. So we can know by these receptors, we can know which one is T cells, which is B cell, which is the natural killer cell. They call it hand marker. So some of these receptors is for identity. And some of the receptors is for their function. By recognizing this functional receptor, we know what the cell is doing at that moment. If you take one T cells out and look at their marker, we know what stage of activation these cells is and what they're doing. So they show the function, they show the identity, and also some are very important for the migration. The cells are moving from one place to another, and this migration is not just random. It's all well organized. So this orchestration is done by the receptor. They call it homing receptor. For example, if you take T cells from the gut of the mice and inject it in the tail of the mice, the cells go exactly where you take it out. Because they know where to go, they know exactly what to do. Their job is precision. They know exactly what to do. If you do whatever this immune system is doing, you will be perfect out. Because all the system is completely perfect. There is no mistake. If one mistake happens, you will be in trouble.
Doctor.
As I said, one of the marker we use for the identity.
The CD receptors, the components of collection of neutrophils and WBCs and what? The collection between WBCs and protein. It makes the receptor.
No. Receptor is on the cells.
Outside.
Yeah, the receptor is outside the cells. The some of the receptor is there all the time. For example, this receptor, the cells carry it all the time. But some of the receptors come and go. We'll tell you in detail, don't worry.
But the formation of this receptor. The formation of this receptor.
Formation is there. Some of the receptors, when we activate the cells, some of the receptors come out. Then activation, take out they go from them, and that causes another receptor to express on the cell surface. We'll tell you all because it's part of the lesson. So far, is it clear? Is it clear? Is it hard? No, it's not hard. What I'm telling you, if you don't read the book tonight, you will forget it. Please read the first chapter and you can encode whatever I told you. But if you don't read it, and then you can remember. If you couldn't join lecture 1 to lecture 2 to lecture 10, you're done. I'm telling you, it is very difficult to even make enough join to pass the test. Because all the thing is joined together, is linked together. It's not like anatomy, because anatomy, each lesson is different from one to another. If you miss the lecture 2, it's fine, you can take the lecture 3, still you can understand. But if you don't take all these lectures all together, you can understand immunology. Because the immunology is the combination of all these lectures together. They are not separated from one another. So please read the book today. If you read it, you can recall whatever I told you, and you can remember it. Okay, so I mentioned that some of the CD markers are for identity, for the identification of the cells. All the immune cells, including monocyte, dendritic cell, eosinophil, all of them have a marker. If you cannot differentiate it by shape, you can use the marker. But sometimes even when they activate it, the shape completely change. It is very difficult to differentiate them. So in that case, it's best to use the marker. For example, as I say, by morphology, the lymphocyte looks identical. You can differentiate T cell from the B cell, B cell from the natural killer cell. The only way to differentiate them is using the marker. So the T cell using CD3. Because I say all the receptor, we call it CD marker. And all these CDs have the number. And each number indicates and related to certain cells and certain function. Because this function is migration and identity. So each number related to the identity or to their function or to their migration. For example, if you have CDX, we know where these cells go. If they express CDY, we know what they're doing. So by looking these markers, we can understand their identity, their function, and their migration. Where they're going, what they're doing, the CD marker tells us. And some of them, which today I'm going to include, is CD markers. We use it for identity. For function and others, we talk about it later. So one of the ways we can use the CD markers is for identification. For example, CD3 is expressed only on T cells, or CD19 expressed on the B cells, or CD56 expressed on natural killer cells. So what we do, we use the antibody against CD3 and label them with the fluorescence color. For example, CD3, as you can see here, is labeled with the red color, and then CD3 goes to bind the T cell, which is in the color. It's T-cell labeling. Or CD19 here, they label it with the green color,
The B cells.
so you can see. So green is here, the red is here. We know that all is B cells or is T cells. So the CD markers are for identification, and they use the immunofluorescence labeling. And this labeling can be recognized in three different ways. One, they call it flow cytometry. This is a technique used to identify these markers, or by immunofluorescence microscopy, or by immunochemistry. So these are the techniques we use in these markers to differentiate, to know the different cells. Okay?
Yeah.
Okay, so we tell you about the cells and what kind of the cells there are in the immune system. So now we're going to talk about how the cells collaborate with each other. So do you have, if you have any questions so far, just raise your hand and then we go to the next section. Everybody understand it or nobody understand it? And there is no question, it's very, not very, looks very good because I think nobody understands what they say.
Can you repeat the slide the last slide?
The last slide. This one.
I think it's about the scene.
This one.
Yes, see. After yes,
Yeah.
I did understand.
Okay, I'll tell you again about this. So all these, as I mentioned, the immune cells, there's two ways to differentiate, to diagnose which cells there are. One is by morphology, another by the markers, CD markers. Each cell have different markers. Each of these cells have different markers, CD markers. For example, T cells only express CD3. No, they have, I'll tell you later because the T cells is, oh yeah, there is different subset. I'm not going to go through that because I'll tell you later when we go to cell-mediated immunity. Little by little, I expand it. But at the moment, we call it T cell. It can be helper T cells, cytotoxic T cells, or any Th1, Th2, Th17, because all of them have different markers. No, I'm not going to go into that because if I tell you that, you will be confused. Yeah. But all of them is T cells. Different subset, but they are T cells. Yeah. Okay, so we're using the marker for differentiation, and each cells have different markers. For example, if the cells have CD3, definitely they are T cells. If they are CD19, definitely they are B cells. If they are 56, they are natural killer cells. Or if they are CD14, this is monocyte. If they are, for example, CD15, is neutrophil. And if they are MAC3 is mast cell. So each of these cells have different markers. If you cannot differentiate it by morphology, you can use CD marker to know which cells there are. So this is the marker for the lymphocyte. They can differentiate T cells, B cells, and natural killer cells. The method we're using that is by flow cytometry, immunofluorescence microscopy, because you can look at the microscope. If it's the B cell, if we stain it from the B cell have to be green. If you see the green color, you know it's the B cell, because the T cell never gave the green color. If you saw the red color, it's known as the B cell. It depends how you label. You can label them either green, red, blue, violet, different color. There's different label. What color? Yeah, it depends on the color you use, you can differentiate. So always, it doesn't mean that always you have to use, for example, green for CD19. No, you can use red. You label the antibody with different color, and you know which label you use for which city marker. So when you saw it under the microscope, you know which cells they are. Or if you run it in flow cytometry, the machine will tell you what kind of color is that. That flow cytometry is very important technique actually. They use it in hospital. If you go to the hospital, you will see it.
And if Dr. H, CD marker has own color, different color from each other.
Yeah, you can put any color on these markers. It's up to you. You can put any color, but you have to know which color used for each marker. And when you know it, you can see it under the microscope, you know which cells there are. It's very simple. Is it clear? So it is the way the immune reaction happens. So the bacteria get into the body, when they pass through the first barrier, they come from the epithelial cells. If they pass from the epithelial cells, neutrophil and macrophage, we saw is a phagocytosis. They try to engulf them and destroy them. At the same time, the dendritic cell take the antigen. And also there is another element which is important for innate immunity, is the complement, it destroys them. And also natural killer cells kill the cells. So all this happens in the first 6 to 12 hours. In the same time, the antigen, when they get into the body, the B cells will recognize the antigen, and the same antigen can be presented by dendritic cells or macrophage to the cells. Because here, to listen, because here the real immunology is going to start, because the first was just introduction. However, we will tell you the detail later, but here is the overall picture of the immune reaction, how it's going to happen. If you don't understand it here, because if you understand it here, you have overall picture, but when we tell you the little by little in detail, you can join them together. So, as I mentioned, some of the function of the cells are, some of the function of the cells phagocytosis, some just destroy them, and some, like dendritic cell or macrophage, they are antigen-presenting cells, if you remember. So what the antigen-presenting cells do, they take off the antigen and present it to T cells. But the B cell can recognize antigen directly. So when the pathogen comes into the system, the B cell recognizes it, and the T cell receives it by the macrophage or dendritic cell. As soon as they confront with the antigen, the number of the cells increase. So the number of the cells increase, and the B cell produce antibody, and the T cell produce cytokines. And these cytokines help the macrophage to destroy the cells later. We call them the effector function. So as you can see here, they take hours, but take days. So if the bacteria have a toxin, the toxin affects very quickly. But as you can see, for development of the innate adaptive immunity, you need at least 5 to 7 days. So 7 days is too long. If you wait for the adaptive immune system to confront the bacteria toxin, the person will die. So that's why the passive immunity is very important. You use anti-serum to eliminate the toxin, and then when the immune system develops, they destroy the bacteria. You understand that? Because the effect of the toxin is very quick. In snake, for example, the snake bite is very 1 hour. It is very deadly. So the immune system cannot do nothing. So the only way is to use passive immunization, transferring the antiserum from the one immunized person to the victim. So this is a different type of the adaptive immunity. So first the bacterial pathogen gets into the system, and then the lymphocyte responding, and then there is an effector function, and then elimination. This is this four step. We have two types of the adaptive immunity. One called humoral immunity, another called cell-mediated immunity. So if the bacteria is extracellular, they don't go inside the cell, it's extracellular, the humoral immunity is responsible. In that case, the B cells produce antibody, and the antibody destroys the bacteria. But if the bacteria is intracellular, the cell-mediated immunity is important because the bacteria goes inside the cells and the antibody cannot affect it, their cell. So the humoral immunity cannot do anything. In these cases, cell immunity comes to the matter. So what they do, they activate the T cells. The T cells have a signal, cell contact, but I told you how the immune system forms as a two-way. One is by receptor, the second way by the protein cytokine. You can see it here. So the helper T cell have a contact with the receptor with these cells, infected one, at the same time produce the protein. So they activate the macrophage, and the macrophage destroy the bacteria. Or if the epithelial cells infected with virus, these epithelial cells express the antigen on the surface, and the cytotoxic T cell recognize it, and they can destroy it by cell-to-cell contact. By the receptor, they destroy the infected cells and the bacteria. So in the last 5 lectures, I will talk in detail about these mechanisms. Okay, that is. I said there is two systems. There is innate immunity and adaptive. Innate immunity is identical to everyone. I said that adaptive immunity is different from one to another. And here they show what the adaptive immunity is all about. The property of the adaptive immunity. One of the functions of the adaptive immunity is specificity and diversity. It's diversity and specificity because each person has their own markers and they have diversity. It's completely different. Another thing that you will heard a lot is pleural expansion. So, as I told you, the lymphocyte, all the lymphocyte is generated in one model from one single cells. So they produce different B cells. As you can see here, these B cells in the color, they show it in by color and the shape of the receptor. So you can see that this one is different from this one, and is different from this one. So they have different color, they show different color reaction, they don't have different color, but they have different receptor. So you can see the shape of the receptor here is different from one to another. So one person, they generate different type of the B cell with different receptor. Each of these B cells can interact with one pathogen. So, for example, is antigen X or pathogen X entering the system, it can react with one of these cells. For example, this one match with this one and activate this one. But this antigen cannot interact with this one. They shows diversity. And also, since it's bind only to this one, it shows the specificity. So one antigen, one B cell is specificity. And since each antigen cannot bind to all the T cells, to show the diversity of the B cell, there's different B cell. Each B cell is responsible for each antigen. If you have 1 million antigen, you have 1 million different B cells in the body. So when the antigen confront their own B cell, they increase the number. So in the beginning, the number of the B cell is very small, as you can see. So what they do, they just activate those B cells can respond. So when the antigen confronted these B cells, the number is increased, but not this one or this one. They call it coronal expansion. Because each one, they call it clone, one clone. So, what is the specificity? This is very important, we have to understand that very carefully. The specificity is based on what? On the receptor they have. The receptor is completely different from one to another. If you have 1,000 or 1 million pathogen or antigen outside, you have 1 million different B cells with different receptors. Each of them, we call it clone, one clone. So each clone can bind with one single antigen. If they confront it, the number will increase. Because before confrontation, their clone number is limited, it's just a short number. As soon as they confront with antigen, only that clone will expand. They call it clonal expansion, meaning increasing the number, that is specific B cells. It shows the specificity. Since they have different receptors, they have diversity. So do you understand the specificity, diversity, and clonal expansion? Because in the book, it's not described as I'm telling you, because I cut the book in different parts. You can see it. But if you don't understand here, you cannot understand from the book.
Again, diversity.
Diversity means they have different receptors. Each cells have different receptors, and each receptor is responsible for single pathogen. This diversity.
Specificity is about B cell.
The specificity means each clone only can bind with one antigen. These B cells never can bind with antigen Y. The only time they bind is when the structure of the gene X is matched with this. So this clone only bind to antigen X. This clone only bind to antigen Y. For example, this clone can bind with the diphtheria. This bind can bind to tuberculosis. You know, each cells can interact with different antigen. This is the diversity, and since they can bind with one antigen, this is specificity. The different version of one B cells, yeah, is clone. Loud. Clones means, alright. So, as I said, you know, it is the lymphocyte mother. It's in the bone marrow. All the lymphocytes generated from single cells. Actually, we will tell you in adaptive immunity in the 5th lecture again. I will explain you in detail. I'm not going to go in detail at the moment because it's early. But I'll tell you how they generate. It's very complex situation. I'm not going to confuse you at this time because little by little we will learn more. So these mother cells in the bone marrow can generate different cells. Okay. Why they are different? Because their receptor is completely different from one another. So each of these cells, we call it one clone. The clone is the identical B cells with the identical receptor which can bind with identical antigen. That is one clone. Okay, there was another. I can hear you. Here. This one. The current expansion, simple explanation is that as when each clone confronts with the antigen, the number is increased. Is the quality forget about this. Also, the simplicity is that when the clone confronts with the antigen, the number is increased. It's called clone expansion. The number of that clone is increased. Basically, each of them is a clone. So when these clonal B cells confront with the antigen, only this one is. No, it's one, they become hundreds and thousands later. You call it kernel expansion. Another property of the adaptive immune system is induction of the memory cells. The memory cells means that if you confront one time to the one pathogen, your body can be able to reject the same antigen if you expose to them later. So how they do it? By doing the memory cells. So once again, the same pictures. So it's the B cells and the T cells. When the naive cells, naive means those cells never confronted with the antigen. If the cells don't meet the antigen, they call it naive cells. So naive cells means the cell doesn't have any experience confrontation with the antigen. Naive cells is those cells never met the antigen. So that the B cell or T cell come to the body, they might not even confront with the antigen, they die. They are naive cells. Naive cells doesn't have any function. They don't do anything. But if they confront with the antigen, the number is increased, as I mentioned, kernel expansion. And when they proliferated, they differentiate. Differentiation means their job becomes separated. Some of them become plasma cells, they produce an antibody. Some of them become memory cells. Okay? On the T cells, also the same thing. The antigen present to the T cells, the T cell number increase, some of them become effector cells, they produce cytokine, and some of them become memory cells. Do you understand? This is clear. So the antigen activates the T cell, the naive T cell and B cells, the number is increased. When the number is increased, their function is differentiated. Some of them produce antibody, some of them become memory cells. It's the same thing here. The T cell number increase, some of them produce cytokine, which is important, and some of them become memory cells. Yeah, another function of the adaptive immunity is the specification. In the specification, in this figure I gave you before, so they make different clone. Each clone confront different antigen, and when they confront the antigen, it is the kernel expansion we mentioned. And some of them become plasma cells, they producing the antibody. And the antibody which produced here only are capable to bind to the same antigen. Is the specification. So this antibody produced here never bind with antigen Y. You understand? This is very important for diagnosis. So interaction between antigen or antibody in the lab, we use it to diagnose the diseases. For example, you have a patient, you want to know the person have a brucellosis or typhoid or typhoid paratyphoid. We don't know. What we do, we take the serum of the patient. What is included in the serum is the antibody. So we put the antibody on the plate, and then we confront it with different antigen. If they bind with the antigen, we know which diseases they have. So the antibody is identical, the antigen is different. If the reaction happens, we know the diseases. Why? Because the specificity of these antibodies, each antibody just can bind with their own antigen. Is it clear? Everybody, that's very important because all the diagnosis in immunology is based on the specificity of the antigen and the antibody. But we use a different method to do it. So these antibody produced by these cells only can destroy these antigen. And these antibody produced by these cells only can destroy these antigen. If you have immunity in one pathogen, it doesn't mean you have immunity against the others. It's almost finished. Another property of the adaptive immune system is contraction. Because if the number of the cells increase in thousands, so your body should be full of the cells. So what will happen? So here, what you can see here, B cell and T cell activated by antigen, they proliferate, differentiate, producing antibody and effector cell. As soon as they destroy it, the cell will die. They die by apoptosis. So they come back to the baseline again. The number of cells come back to the baseline. But what you have, you remain in some memory cells for the next time. So all is the property of the adaptive immune system. You know how well they are organized. When I go through all the detail, you will enjoy it, to be honest. It's very interesting stuff. So we have two types of the deal. One is apoptosis, means physiological thing. One is necrosis, is completely different. It's a physical thing. For example, if the viral infected, you have viral infected, the virus kills the cells by necrosis. You mean they destroy the cytoplasm and destroy the cell, but apoptosis destroy the nucleus and then the cells die. Yes, you have a question. No, here, coming here. Yeah, the number of the cells increase and they produce their antibody and cytokine. And these antibody and cytokine finally eliminate the bacteria. Since there is no bacteria, so the cell is not activated anymore. That's why they die. So this is the property of the adaptive immunity, which I mentioned all in detail. So we have primary antibody and primary and secondary immune response. So here we have two antigen X, antigen Y. So in this stage, we just use the inject antigen X. What will happen? The B cell and T cells increase, as well as mentioned, they produce the antibody and then decline and make the memory cells. But here, if we inject antigen X and Y, you can see that the antigen X, the number is increased much higher than this one is lower. So the secondary response is done by memory cells, but the primary response is by naive cells. So what is the difference? Memory cells, the production is high, and it's even faster. It's much Yeah, but here in primary response, for example, if you get infected, in primary response, you have the symptom of the disease. You have a fever, you have all these problems. But here, you even don't feel it. Before you get the symptom, the immune system destroys the bacteria. Why? Because the magnitude of the response here and more effective the antibody they produce and faster they produce. That's why we don't feel at all. That's why we have the immunity. If you look at the Greeks here, you can find out why, because it's very fast. So this is the character of the B-cell and T-cell. As you can see here, for example, lifespan. These are naive cells. They die after weeks and months. If the B-cell produce, if they don't confront with the antigen, after months they will die. Another one will generate later by the whole time. But when they were activated, they die after days, 5 days, 6 days, as you can see. Yeah, after they found the job, they die. But the memory cells came back. So this is the, we can see it as not very important. How they stay long? You want? What's the question? How they stay long?
Okay, how they stay long?
Nobody knows the first answer actually. It is one of the targeting immunology. I was one of the person that had a theory of that. Full microceptor is one of the ways. No, just leave it. Nobody knows the answer. In this stage, if you ask me after we finish the immunology and then we can discuss it better. Because at the moment, you don't know the basic knowledge about the immunology. If I talk with you, you can understand. Just leave it, ask me after okay. Write the question in your paper, ask me later, because if I explain to you, you can understand it. Okay, that is the whole story, the whole thing that I mentioned to you today. So, we have B cells, we have T helper cells, we have the cytotoxic T cells, and we have natural killer cells. So the B cell come from the microbe, they produce antibody. The antibody, with the help of the complement, they destroy and neutralize the pathogen. The T cells produce the cytokine, and this cytokine help monocyte, and the monocyte kill the pathogen, and also they help neutrophil in inflammation, and also help the B cells to produce antibody. And the cytotoxic T cells, when they receive the signal from the infected cells, they destroy and kill the infected cells. And the same thing do by the natural killer cells. Natural killer cells doing, but the difference between these two is the cytotoxic T cell. They are specific, mean a specific antigen, a specific pathogen, but these cells doesn't have the specificity. So we will tell you the detail of all later in the class. Finish. So did you understand? If you have any question, ask me now.
I didn't understand what the meaning of naive cells.
Well,
What's the meaning of naive cells?
naive means they don't, for example, the bone marrow produce a cell, they come to the blood system. They don't need antigen. If there is no antigen for that cells, they are naive. Naive means they don't have any experience of replication. No, they don't confront it yet. So, for example,
انا اقول لك عقبال ما تظبطها عقبال